We first use complex numbers to talk about square roots of negative numbers. We know that these are not real numbers. We have a way of representing these numbers using the letter I. Square root of negative 1 we define as equal to I. From there we can simplify other square roots of negative numbers. Since we know the square root of 4 equals 2, the square root of negative 4 equals 2i. And if we encounter radicals that are irrational, we would still like to simplify them. Square root of negative 12 equals 2 radical 3i. This prepares us to deal with solutions to quadratic equations that are complex numbers. We know we have a quadratic equation that will give us complex solutions by looking at the discriminant. That's the quantity b squared minus 4ac, where a, b, and c are the coefficients of this equation in standard form. b squared minus 4ac, now in this case a, b, and c are each equal to positive 1, and our discriminant is negative 3. When we plug that quantity into the quadratic formula, we would see these two solutions. Whenever the discriminant is negative is when we come up with a negative quantity in the square root in the quadratic formula, so it must be a complex solution. We would simplify this square root of negative 3 just by bringing an I outside of the radical. X equals negative 1 plus or minus I radical 3 over 2. And we could take this number one step further and split it up into two separate fractions. We have only one term in the denominator, 2, so it's legit that we split up the numerator, and we end up with the real part and the imaginary part of this complex number as two very distinct terms. Negative 1/2 is the real part. The square root of 3 over 2, the coefficient of I, is the imaginary part. Together they'll make the complex number. And because it was a solution to a quadratic, we know we have two separate answers here. Negative 1/2 plus radical 3 over 2i, and negative 1/2 minus radical 3 over 2i. We begin to see some very interesting and useful things when we plot complex numbers. We do that on a plane with horizontal and vertical axes. Instead of x and y for the axes, we're going to have a real axis and an imaginary axis. The little script RE for real and IM for imaginary. It's working just like an XY coordinate plane, so these are two number lines. To the right, positive numbers, and to the left, negative numbers. So real on the horizontal. The imaginary will be using the coefficient of I. We're going to leave the I off. Understand that this vertical axis represents the imaginary part, the coefficient of I. It's a pretty crude sketch of a graph here, but we can figure out approximately where these points are. Negative 1/2 plus radical 3 over 2. So first plot the real part, negative 1/2. We're going to the left, negative 1/2. And if we use positive radical 3 over 2, that's a positive number. We're going up, and we have a point there in quadrant 2. There's the point negative 1/2 radical 3 over 2, just using the real part and the coefficient of the imaginary part. Our other solution, negative 1/2 minus radical 3 over 2. So we have the same horizontal negative 1/2, but our vertical is now negative from the negative radical 3 over 2i. And we see these 2 points are reflections about the horizontal axis, and hopefully these ordered pairs are jumping out at you as well as being familiar from points on the unit circle. We know the angle measures here, the point in quadrant 2 is at 150 degrees, and down here in quadrant 3, 240 degrees. So this complex number, this pair of complex numbers that were solutions to this quadratic equation, when we consider them to be points that we plot, the real part and the imaginary part, we can incorporate our trigonometry knowledge when working with complex numbers. That we don't have to keep them in this a plus bi form, we call it, but we can look at them in terms of their radius and their angle measure, and that's what we're going to do in this video.